It is usually harder to visualize a third-dimensional shape than a two-dimensional shape. But why? See, the reason is the third-dimensional world works very differently when compared to the two-dimensional world. But how? Again, if you really think about it, two 2D shapes cannot overlap in any given circumstances, while two 3D shapes can. While objects of the same size will look the same in the second dimension, it won't be like that in the third dimension, unless, of course, they lie on the same plane, which would make them two-dimensional again. And from this, we can deduce that objects become smaller as they move farther away from the observer's eye and become bigger as they move towards the observer's eye. And this, my friend, is what we artists call perspective. When traced, all 3D parallel lines seem to intersect at a point. They never truly intersect at a point, but in a 3D image, they seem like they want to. But what is that imaginary point? You might ask me. That imaginary point is something that we artists have collectively decided to call the vanishing point, because it's a point beyond which our visions don't work. And the end of the point where our visions don't work, it's marked by a line called the horizon line. This is the point where the vision of a human being ends. It could be brought closer or farther away by fog and other elements, but it's mostly drawn with taking the perspective point as the center, and a line is drawn parallel to the bottom of the paper. This is how this type of work works, or this is how perspective works. Now let's try to draw a sketch of a cube normally, and then we'll do it in perspective. When we're drawing a cube normally, we don't give it any depth. It's basically two squares that are connected by four lines. What could be so different about the cube? You might say nothing. But see, that's a very huge difference between the perspective and the normal cube. In a perspective cube, we draw parallel lines that originate from a singular point. And the parallel lines that originate from a single point kind of intersect at many intervals when we're using another perspective point to narrow down the perspective of the cube. And now the cube truly looks realistic and cuboidal. A cuboid has 6 faces, while a normal square just has 1, which means that 6 planes form one cube. What can we deduce from this? We can say that a cube is created by 6 faces that comprise of 2 perpendicular lines perpendicular to each other, followed by 2 other perpendicular lines that are also perpendicular to each other and equal in size. Okay, so now that we know the basic idea of what perspective is, we can basically use perspective to help our viewer streamline their sense of vision better. How do we do this? Contouring. What are contours? You see, a disco ball will look more 3D than a cricket ball with one single seam. Why? Because there are more guiding lines suggesting to the viewer that hey, this thing, it might be 3D. And in the case of a Rubik's Cube, it seems more 3-dimensional than a normal cube itself. And it is because of the same reason. And if you really think about it, you can draw contours around literally anything. You could make a normal ball a disco ball, and that would look more 3D. You could make a disco ball a disco-er ball too. That's possible. And yeah, that was the basics of perspective. Today, I've covered what one-point perspective is. And 3D parallel lines, they seem to meet at 3 points across the 3 different axes that are the X, Y, and Z. That is a more complex topic, and that is a topic we'll be covering in the next set of videos. That's it. You've learnt about form.